Hi, I've got some good optimizations to this video making process. I've got a timer, so I'll be able to tell how long the video is going to be, and I'm hoping the audio is going to be a lot better. Sorry for those last videos, the audio were terrible. I think the content is good though, so they might be worth going back and listening to, but unfortunately for now, I'm just going to do what I can about the videos going forth and just leave those up there as is. So let's continue going through and verifying the same topology in the last video. So in the last video, there's a problem with the OSPF connection between PE1 and CE1. You can see right now OSPF route instance VPN2 CE1. That's now verified. It matches exactly what's shown in the verification step. So now on router PE1, we're going to use the command show route advertising protocol to verify that router PE1 advertises that loopback that it learned from the CE1 all the way over to ASBR1. So it's not all the way over, it's just over to, let's see here, yeah, this ASBR1 here, and that it's using MP BGP with the VPN MPLS label. So we can even do a Wireshark capture, look at the BGP traffic and verify that that label is showing up there in addition to just doing this. So let's start with that command though. Hopefully everything looks good when I run that. Otherwise it's going to turn into a troubleshooting video as the last one did. So yep, everything looks great. Different number of destinations and routes, so that might be something to think about later, but it's got that loopback address from C1. It's got a VPN label. It's going to be a different label, but there's nothing wrong with that. I'm not sure how the labels assigned. I think that's beyond the scope of the IE. That's even more advanced topic than that. But so let's keep going and do the next command. So we're going to use the show route receive protocol. This was advertising protocol. So we looked at what this PE1 router is sending out to all of these other devices. Now we're going to look at what the PE router is receiving. Show route receive protocol BGP 192.0.22 extensive. So it looks like we've got a few differences here aside from what's shown in the example. So we're just trying to verify that the router receives and accepts 192.0.2.1 route, which is interesting because if it's a .1, that's normally a host address. So right away there, that's a clue as to what kind of route that is, because if it were a /24, it'd be a .0. The fact that it's ending in a odd number like that, .1, means that it's definitely a /32. There's no other kind of route network address that could be ending in an odd number that is not a /32. A /31, let's say you had 192.0.2.2/31, well, then you would just see the .2 in there. You wouldn't see the .3 because that's the network address of the /31, even though it's they're both host addresses. If you took a look at the RFC I mentioned in the other video, there's more information about that kind of outside case. But in this case, we've just got the /32 here, and I'm guessing this is from the other CE. So let's look at that other CE. Let's log into that other CE and make sure that it doesn't have the same error that was on the other one. So this is going to be CE2. So let's just do a show type compare because I might have entered it but never hit commit. Nope, it's in there. So let's do a show configuration, display set type no more. So, oh, it looks like we've got .8 instead. And actually, so thinking closer, this is going to be to ASBR2, as I mentioned. So really, for this to be a IP address on CE2 probably doesn't make as much sense as it being an IP address we expect to receive over there. So one of the things I'm going to do as part of this troubleshooting is just look back and see where this was meant to be configured. So I would be willing to bet it's either ASBR1 or ASBR2 where this is meant to exist. So I actually don't see it anywhere. Here we go. So okay, this lives on CE1, and that makes sense. I remember it from the last video. This was the loopback address that was missing from CE1 that I eventually was able to resolve the issue by adding. So this says that show route receive protocol extensive has this being learned. Okay, okay, that makes sense. So yeah, it's going to learn over that, and it's going to treat it. It's going to process it in this special route table. So show route. Let's just enter that command again. Receive protocol BGP 192.0.2.2 extensive. So, oh, and I did it on the wrong device. So I'll type it out again because I'm not 100% like learned in this command. I really haven't used it in a professional production type situation. So the more I can actually type it out, the more practice I get with it, and the more I will be able to use it if I ever do have the chance to use it in production. So we've got, let's see here, just hit that again. So yeah, we've got all the routing tables here. It says that it's going to show up in this one. Unfortunately, I don't see it showing up the same way here as it does here. I do see it's got the same amount of destinations. So let's just take a closer look. Into that table specifically. There we go. So now we're actually printing out the table. We're not just using this filtering command. So hopefully we can see the route that it actually wanted. Yeah, so we can see it there. We can see it's a OSPF route. Unfortunately, we can't see any of this route distinguisher information. That would be nice to see. What about just route receive protocol and then BGP, and then, oh, we got to put in a neighbor. So, I mean, this makes sense when you think about it. I think this actually might be something we're going to need to downvote and report to Juniper, because if it's going to be receiving a route by the BGP neighbor here, 192.0.2.2. So if I do show route, I've got 192.0.2.2 right here. So that is my own loopback address on this. Oh, okay. So a good lesson here. and I think this was all pretty valuable for people to see just kind of how I understood this. These are meant to be applied on the ASBR. So the command here is working. So let's take a look at the other command meant to be on PE1, and then after that, let's go over to the ASBR. So on PE1, the command is meant to be this show route advertising protocol. And that's a good lesson at how important it is to really get comfortable using show commands, really have a really strong sense of what you're doing before you make any changes, because it's easy to get confused, that's for sure. So we can see, yep, we got all the route distinguisher information there. We've got the VPN label. This, at the beginning of the video, I remember running this command and seeing this was all good. The only issue was when the directions said to move on to ASBR2, I stayed on PE1. So let's open, oh, sorry, ASBR1. I stayed on PE1. So let's go to ASBR1 now, and we'll save ASBR2 for later. And so far, the video is about 11 minutes, so I'll definitely cap it off on 20, but hopefully we can continue here. What to call BGP 1 and 2. So, and then I've got that more prompt, so I'll just tab that all the way out. And yep, this looks a lot better, which makes sense because we're not going to be receiving that loopback like receiving from a neighbor. So here we don't even have the neighborship we have with this CE. Let's take a look at that, at what's configured on the CE, so we can kind of understand how these two devices are connected. So it's just a OSPF neighborship. That's the only way these two are connected. So if we're going to do a command like show route receive protocol BGP on PE1, we're going to look at routes being received this way. So it doesn't make sense that we'd be receiving the loopback address of CE1 this way. You'd have to receive it this way. And you're not going to receive it through BGP. You're going to receive it through OSPF. So this makes perfect sense if you run it on ASBR1, but if you run it on PE1, the only thing that makes sense to have here is the address here on this, was the address of the BGP neighbor, which is going to be actually over here. So we can actually find out the BGP neighbor. It'll have only one neighborship just by doing show BGP summary. And yep, sure enough. And unfortunately, sometimes I haven't figured out how to get that word wrapping to really look nice and pretty. I'd rather have it just kind of run off the screen and then have a slider bar down here, but I can just maximize it and get everything I need. It's really not a big deal. And you can see, yep, it's only got one BGP peer because it's just using OSPF for the CE. And that BGP peer is going to be on the ASBR. So if I did a show configuration, display set pipe match, and then paste that in there, that's going to be on the loopback here. So I'm forming a BGP connection, multi-hop connection from the PE1 here, loopback to the loopback on ASBR1. So just to drive that home, here's the PE address there on the loopback. Here's the neighbor, 024. So, oh, might actually have an issue. This is kind of a good kind of foreshadowing into what some of the videos might be in the future, because you can see you wouldn't want this to be 024. I'm actually very surprised the connection is up at all. But sure enough, state established over to 024. Here, let's take a look. Show BGP summary. State established. Oh, so, oh, I see. This is just the local address. It's just specifying that it's going to be using that address here. This does not say the neighbor. So let's take a look at the actual BGP configuration for that particular group. And yeah, now you can see the neighborship is actually formed with that 2.2. So everything's good since state established. The BGP is great. So let's go ahead and close this, and just so we verified that this looks good. Let's just run this command to make extra sure that this down here is good. So we got to open up the ASBR1. Perfect. So now we're going to do show route receive protocol BGP 192.0.22 extensive. And yep, it looks like everything's good down here as well. And this looks very similar to that information that we saw on PE1 up here, because yep, it's going to be in a different table, but it's going to be, looks like the same information. So this here is essentially a BGP L3 VPN table, even though it's not named that. So looks like they have very similar information in them. There's a few differences. Here's a different flag, next hop change, next hop self. So those are going to be important ones. Community should be the same. AS path, I. So here it actually looks like it received it through an additional hop, or sorry, through another AS path. It looks like it went through an autonomous system 100, which if we look at our, here we go. So it looks like it just calls out the AS that it received the route from internally. So yep, we've got a little bit of extra information up there. We've got that extra 100 there. And here we just got the I, but let's continue, and hopefully we'll keep having everything go smoothly and not run into any more issues. So now we're going to verify that router ASBR1 advertises the 192.0.2.1 route to ASBR2. So this one right here. Show route advertising protocol BGP 192.168.3.8 extensive. Looks good to me. Everything is good. And one thing I want to verify quick. So I mentioned before that you're going to need a special command to have a multi-hop BGP connection, but I have noticed that that is not something that is included in this configuration, but the configuration still works. So I thought I had a better understanding of that, but unfortunately it looks like I do not. But it's of course always just a read away. So maybe it's only required for eBGP and not required for iBGP. That's something for me to look into and understand more. If you can link to a good article on that, or help me out in the comments, that'd be very much appreciated. So let's keep going. ASBR1, show route advertising protocol BGP 192.168.3.8 extensive. That looks great. Now let's go down here to ASBR2. So bring this back up and got ASBR2. So let's do show route receive protocol BGP 192.168.3.7. Oops. And here's a great one for people who are perhaps beginners. You can do Control W and you get rid of everything to the left of the cursor. The other thing is if you just make complete mistakes, you can do Control U and you just get rid of everything and you can start over. I do that a lot because I just kind of sometimes get ahead of myself when I type and I do like true instead of show. And then everything's all messed up beyond that. So then I'll just do a Control U and I'll start again and hopefully get it right. So that's a good one for beginners to know. Another good one, Control A takes you to the front of the line. Control E takes you to the end. And that's great because if you do like a show configuration and or let's say you want to do a show int descriptions. Well, well, these are bad examples, but let's say you wanted to do something that you could only, okay, I get it. So let's say that you were in configuration mode and you wanted to do show interface descriptions that you can only do if you're not in configuration mode. If you're in configuration mode, it's an invalid command. So let's say you type that in by accident and, oh, I forgot to run. Well, instead of doing run, show, like that, you can just up arrow, Control A, run space. And you can kind of jump around and make up for mistakes by having that Control A and Control E hotkey memorized. It can really help you to be more fluid and comfortable on the command line and not kind of be as inefficient. So it looks like I'm at the 22 mark for the length of this video. I'm just kind of feeling it a little bit right now, so I'll just keep going. Hopefully everything here looks great. Yep, everything looks good here. So it's accepted. It's got the next hop. So now let's do the next command, show route advertising protocol BGP extensive, and this is the neighbor, which of course we know the neighbor here. So okay, so here we specified the neighbor that was going to be to router 1. So if we do a show BGP summary, we're going to see that neighbor here, and it's going to be using a special routing table called to ASBR1. So very clearly here we're looking at, in this topology, stuff being received down from here, from ASBR1. And we can see our good old friend 192.0.2.1 that was configured on C1 that actually made it all the way down, and it's in this special routing table on ASBR2 named to ASBR1. That's where it's being learned because ASBR1 is sending it down there. So now we're going to take a look at the other side here, and we're going to look at the routes that ASBR2 is advertising out to these other routers. And yep, that's going to be that loopback address from CE1. That's how these other routers know about it, is because ASPR2 is going to advertise it out to them using BGP. So let's make sure that we get output from that command that matches the exercise. So it looks like we've got a little bit of an issue here. So I'll just kind of do a sanity check. Yep, this is meant to be on ASPR2. Let's do some more sanity checks. Yep, I put in the correct neighbor. I used extensive. So it looks like this ASPR2 is actually not advertising any routes out to its neighbor here, its BGP neighbor there. So let's, as a first step, let's see if that neighborship is even up and in established. So show BGP summary. And here we can see, of course, it's not going to be able to advertise any routes out to there because that is actually inactive. It's not even in established, which is the state it's got to be in for BGP to actually send or receive routes. So there's no wonder that it's not able to send those routes. So let's start out by just pinging that, because we're going to need to form a TCP connection in order to have a BGP neighborship. So it looks like there's no route to that host, so it can't, in the routing table, show route. And I can actually narrow it down more. So yeah, we've got this. So let's just do a show route on that. And one thing that's nice about show route on Junipers, I think you can do this on other devices, is you can give it a host address and it will show you the route for the network address. So here I've got a route for 192.168.4.0/24. So I can actually check that route by giving it a host address like 50, and it will automatically know to show me the closest match to that, which is that /24. So you can check a route by giving it a host address. So we can see very clearly when I did that with 2.7, there actually are no routes that host address would fall into a network of. The device just doesn't know any networks where that host address could belong to. So let's try to figure that out. Actually, let's end the video here. I think it's kind of a good stopping point. I'm up against the 30-minute point, and in the next video, I'll go over and I'll try to figure out how I can get that neighborship from active into established, and keep running through the verification commands, and hopefully have this whole exercise work in just one other video. That's kind of a stretch. It might take more than that. All right, thanks for watching.